Hello, everyone, and welcome to tonight's conversation. My name is Sophie Buchanan, and I am a director and facilitator with an organisation called RPS. We've been invited to attend this evening by Powercor to support the conversation about electromagnetic fields and water management at the Ballarat East substation as planned. We've got quite a lot to get through tonight, so I do just super quickly want to let you know that you have come into the chat on mute with cameras off. You will have access to the chat. I also want to confirm that tonight's session will be recorded. This is so that we can put it up on the website or share it later with people who were not otherwise able to attend. Please know that you can absolutely use the chat at any stage to ask questions. I'll run you through the order of events in a moment. We will be dealing with the questions that came in ahead of time first, before we jump into any questions that we might have time for at the end. We'll do the session in two parts. The first part of the session will deal with water management, and the second with EMF, and we will answer the questions that we received ahead of this session after each segment. Before I go too much further, I do just briefly want to acknowledge the traditional owners of the land on which we're meeting tonight. For me, that is the Wurundjeri Woi-wurrung people. For the people in Ballarat and for this project generally, it is the Wadawurrung and the Dja Dja Wurrung people. I do want to recognise their ongoing connection with land, sea and water, their continued care for country, and their deep spiritual connection to it. Before we go too much further, as well, I do just want to reiterate some of the rules of engagement for this evening. We do want to make sure that everybody has a chance to have their questions answered, so please do be respectful. If at any point we do have time to answer questions from the chat, our expectation is that you'll engage with us and we'll engage with you with kindness, respect and courtesy. Please do try to stay on topic. That tonight we are specifically talking about EMF and water management. We will prioritise those questions. If we get questions on other topics and we have time and it's within the subject matter experts' realm of knowledge, then we'll do our very best to answer those. But if we don't, we'll take those on notice. Please do be appropriate in your language and avoid being offensive or inappropriate. And be patient. Some people are more familiar with the technology here than others. If you are having trouble with the technology, do just let us know by raising your hand or putting a note in the chat, and we'll do our very best to support you. If I do feel that anybody is being inappropriate, and by inappropriate I do mean, being aggressive, outwardly disrespectful, to our presenters or to each other, then I will reserve the right to invite you to stop that behaviour. If you don't feel that you're able to stop that behaviour, then you're welcome to take yourself out of the conversation. But if it continues and if need be, and as a point of absolute last resort, we will take people out of the conversation if we think that that's inappropriate. So without going into too much more detail, we will kick straight on to our first presenter. I do want to introduce Amila. Amila is a water management expert from an organisation called WSP. They are the subject matter experts who've been engaged on this project to do the flood modelling and water management design. Amila has more than 16 years design and consultancy engineering experience, and he has a specialisation in water resource projects. He's a chartered engineer and a registered professional of engineer, and he currently leads the National Surface Water Team within WSP's Geo-Environmental Business Unit. This is not his first rodeo. He's done a number of surface water studies and design projects, and particularly focused on risk assessments. So I'm going to go back on mute and invite Amila to take the mic and lead the conversation about flood management.
Thanks, Sophie. Hello, everyone. So I go straight into the flood assessment study that we did for the site Ballarat East Zone substation. So first, I will talk about a little bit on the locality and the existing conditions and the current council flood mapping. and then go into what we found in the study. So, Amanda, if you could go to the next slide. So this is the locality plan. I'm pretty sure that you are much more familiar than me with this area, but I will briefly talk about it. So the site is bounded by the York Street to the south, then Pennywhite Gully to the east, and there's a Cully Street and Warren Heap Gully to the north, and there are a couple of residential blocks to the western side of the site. And it pictures the right-hand side corner is the culvert that serves in the York Street, which is about 375 millimeter smaller culvert that brings all the upstream runoff towards the Pennywhite Gully downstream. And the bottom picture is showing when you're looking at from the side to the upstream towards the York Street. Next slide, please. So this is a context of the locality plan where the site sits on the Ballarat locality area plan. So I mean, executed. Next slide, please. And this is again in the context of the planning authority, site is classified as the utility site. So next slide, please. So I talk about a little bit on the existing conditions. So you probably have seen that slide has some sort of a lowland area towards the York Street. So you can see that little arrows in the blue arrows that shows where the grading of the site towards the north, and that's where pretty much the surface water flow within the site currently runs into. And you can see the right-hand side, the Pennywhite Gully, that's going alongside the site, and there's a little bit of a easement or margin in between the site and that gully. So that area, the lowline area, it is not an intentional flood capacity or the flood basin. It just that what happened in the larger storm events, there's a potential that there would be some flood attenuation in that area. So we will talk more about what the flood condition is currently and what will it be looking at the post-development conditions. Next slide, please. So again, this is the same map that we looked at, but in a bigger scale. And you can see that culvert pretty much that's the main conveyor across the York Street. So I'll talk about in the next couple of slides that what happened to the larger flood events and where the flows you can see across that York Street and around the Pennywhite Gully. Next slide, please. So this is the existing flood conditions, and these are the two maps that we publicly available, and we source from one from the left-hand side. One is from the Ballarat flood modeling, the council flood modeling, which is the latest, I believe, and that also to be noticed that it included the climate change scenario. And both of these maps shows the 1% annual exceedance probability of the flooding, which is in a previous terminology, it is equal to or similar to 1 in 100 year average recurrence interval flood event, which kind of like larger flood events. So you can see even though the color maps are too different, they show the same or very similar results. Within the site, the flood depths are about maximum 0.5 meters, and most of the area is below 0.3 meters. And in that Pennywhite Gully, adjacent to the site, you can see there are only two spots with the red color, which is the flood depth we notice about 1 meter, but most of the gullies flood depths are up to 0.5 meters. And in the right-hand side mapping, that is from the Catchment Management Authority, it shows a slight inundation of flood inundation going towards to the existing properties, but it is again to notice that it's less than 0.3 meters. It's like less than 300 millimeters. We will compare what we develop as a flood model and compare with these results for the pre-development and also post-development in next couple of slides. Next slide, please. So this is the development plan. What important in terms of flood study is that the blue hatch area. So when you're looking from south to north, which is from left to right, then you can see the eastern boundary, the light white hatch area, that's the proposed swale that we are going to build, or the proposed to be built in compensation of whatever the flood loss in the site, existing flood loss in the site, and also to accommodate any potential increase in post-development runoff. Next slide, please. So from there, to assess what happened in the post-development, what we did was that we developed a flood model. Then we develop it to the existing condition. Then we compared it to the flood mapping that is done by the council and the catchment management authority. And then we applied the post-development conditions and sized the what required stormwater management features so that downstream or within the site there won't be a flood risk. When it comes to downstream, we considered these flood safety checks which are like not worsening the flood conditions than what it is now. And the model was developed using T-Flow software, which is the same software that the council and the catchment management authority used. And we used the latest Australian rainfall and runoff guidelines developing that model, and use the Bureau of Meteorology rainfall intensity data. So if you go to the next slide, please. So this one, you can see the comparison of the council model and the pre-development model that WSP developed for the site. So it's pretty much identical in terms of the flood extent. You would see a different color coding, it's just a difference in the color mapping, but the flood depth and the results are pretty much identical. Just to note that the flood mapping that done by the council is considered the large area, so that's why you can see a little bit of a nuances around the edges of the flood extent. But the mainly, as I noted before, the maximum flood depths within the site are going up to 0.5, only a couple of areas, the majority of it within 0.3, and the Pennywhite Gully is mostly around or less than 1 meter, only a couple of spots that are more than 1. Again, in the left-hand side, you would see a little bit more area covered by that flood modeling, because as I say, that was a regional model. The one that we developed was more accurate because we used a finer grid size, but it didn't cover the full extent. We covered basically the side and the surrounding area, just not on that. So if you go to the next slide, please. Then once we calibrated that, compared the pre-development conditions of our model and the catchment authority or the council's model, then we satisfied that our model also represent the pre-development conditions, so we could use it to the modify and use it as a design tool for the post-development condition. So the two images you see, the left-hand side is the pre-development and the right-hand side is the post-development. You can see that dark blue area or the dark blue swale that we embedded into the post-development model. And then you can see what's the flood, especially around the site and the surrounding area. So there's a slight reduction actually in the flood depth, because previously there was a connection from the site flooding directly goes across the boundary into the Pennywhite Gully. But now with the swale design, that's been cut off, and we provided a culvert downstream. So that's why you see a slight reduction in the flood depth in the corner, the northeastern corner in the Pennywhite Gully and the side. But other than that, all the flood depths around the side area is pretty much similar in the pre and post development. If you go to the next slide, please. This is again the flood velocity maps. And you can see there's a slight reduction in the velocities external to the side. So you can see that couple of green blobs, the colored patches are not anymore visible in the eastern corner because of that slight reduction in the velocities as well, similar with the flows. Within the side, there's a increase of flood velocity, the flow velocities, but that's manageable. Only that yellow bit greater than 3.7 meters due to the internal culvert, but that's also, we have to manage that within the site, and we can manage that by adopting a pre-prep or similar sort of a design arrangement in the future. So if you go to the next slide, please. So to reiterate what the findings are, mainly that we propose a swale which has a capacity of about 3,400 cubic meters and 1.9 meter deep. And we will be fencing it, or we recommend to fence it so that public access won't be allowed to that swale. And again, that swale will be within the site, not in public areas. So that's just a safety concern, safety precaution. And the major findings we found out is that there won't be a worsening or adverse flood impact to the adjacent property due to the post-development. Then the velocities that going from swale into the downstream Warren Heap Gully would be less than 1.5 meters per second for 1% AEP event. Then we also did a bit of a case study that what will happen if somebody upgrade the culvert underneath the York Street. So we tested one scenario with the 600 millimeter culvert rather than 375 existing, and we found out that there won't be much of a difference. That's mainly because of 1% AEP being a large event and most of the flooding is going across the road. Then finally, we identified some alternative access during a flood event to the side. That's what you can see in the picture with the red arrows. So that's a summary of the flood study, and welcome to ask questions, and I'm happy to answer. Thank you.
Thank you. Amila, I'm just going to ask you some of the questions that we received ahead of the session. I'll ask them. I'll just let you know. I know we've got a number of the people who asked questions on the line, just so you can identify the questions that you yourself asked. So the first question, Amila, is from Jamie, who asks, I would like to know in what way the team will add flood mitigation. The current drainage will not hold any extra catchment. I feel like you've already answered that, but do you think it's worth reiterating?
Yeah, I can reiterate something that. So the compensation of any flood loss due to the post-development, we will be providing the compensation within the swale that I talked about. So we are not putting any excess water or additional water into the existing system outside the site. So that basin was sized, as I noted before, considering the not adversing any flooding to the downstream or the adjacent properties. So we sized that. So it has a required capacity for the 1% AEP larger flood events.
Great, thank you. Then on a similar topic, Nicole notes that that a swale is planned for water containment and that this site is located within a flood zone. Nicole also notes that there is a new map that's available from the City of Ballarat and asks what impact that will have. I understand, Amila, that that is the map that you had on screen earlier, isn't it?
That's right, Sophie. That's the map that I show. If you remember the slide, the comparing two maps from the Catchment Authority, which was a kind of couple of years old, and the latest mapping from the Ballarat City. That shows what the flood prone area within the site and around the site. So that's what we demonstrated, that the pre and post development flood adjacent to the site is pretty much the same. We are not adverse in it. Thank you.
Okay, that's great. Thank you. Graham asks, how much water will be discharged into the Warren Height Creek?
Yeah, again, it depends on the event, obviously. So what we assess first the 1% AEP, then even within the 1% AEP event, so we are talking about 1 in 100 year similar event, there could be several duration events. For example, it could be 1 hour, it could be 2 hours. So how much water that you're going to put into the Warren Heap Gully, it depends on the intensity and the duration of the event. So we can't have exact answer, but for the scenario that we analyzed, we found out the exit flow would be about 1.5 meters per second or less than that exit in the side into the gully. And also the flow rate could be through the culvert. There's a culvert flow. Flow rate through the culvert that we are proposing would be about 4.2 cubic meters per second for that particular event we analyzed. So that was, in fact, that was the critical duration event, or like a potential large or the mean, potentially mean event of a 1% AEP. So I believe that might answer your question, but we don't have exact answer how much water, because as I say, it depends on the intensity and the duration of the event.
Great. Okay. All right. I think that makes intuitive sense that, the more water there is in the event, then the more water potentially will be discharged to the creek. But I think what you're saying is that it won't be over and above what would have happened under a pre-development scenario. Yeah. Nicole, another question from Nicole. Observing that the Callow Street drain is in existence, it's a small capacity heritage drain, which is already, Nicole notes, been damaged by excessive water flow. It's been fine for 100 years, should not have to update to an ugly concrete drain to accommodate the substation, as this is a heritage area. I think I heard you say, didn't I, that you're not planning to upgrade the drain at this stage. You've done some modelling on that, is that correct?
Not that drain. I talked about the culvert upstream. This is the downstream gully, but we have no intention at this stage. It's like it's external to the site. That's the one fact, and we are not increasing any flows to that gully. So we are not expecting that there is a requirement that address because of the substation or because of the site development, basically. There could be some other constraint. It could be some decisions from council, but that's external to what happened in the site. It's not a cause or not an issue that will be created from the site's flooding.
Okay, all right. Thank you for that clarification. Annette expresses concern that she doesn't believe that a swale will do anything to alleviate flooding in Callow Street because any floodwaters will run into a limited capacity drain. She's concerned that will make flooding in Callow Street worse as a result of the development of the substation. Again, I feel like you've just touched on that, but do you want to just elaborate on that, Amila, further?
Yes, Sophie. So as I say that based on the guidelines and the requirements, what we're trying to do is that we're not changing any flood condition externally. So, for example, currently there is some flood capacity in the site. That's exactly what happened, probably what happened in the site, that there will be some flooding stay at the site. It could be the groundwater, it could be there because of they got a bit of a tailwater, that it will take time to alleviate that flooding in the site. So we are not versed in that. We just make up that flood capacity within the site, and we provided that within the swale. So it's pretty much a similar thing in terms of concept. And in addition to that, we allow a little bit of extra to considering that there will be some impervious area or the increase of impervious area in the site because of the platform. So we allow some capacity within the swale for that as well.
Thank you. And Ben Hatfield is with us also. Ben's from Powercor. Ben, is there anything that you want to add over and above Amila's explanation about the Callow Street implications?
No, I think Amila's covered it really well at this stage, Sophie. So.
Great, thanks, Ben. Another question from Annette. Has anybody looked at the fact that no matter how deep you build your swale, Annette believes that it will fill up with seepage because the swale, or the whole site really, is located in a flood zone. Amila, have you taken that into account in your designing and planning?
We haven't considered the groundwater in particular, But as I say, what we consider is what existing condition. If there's a groundwater implication in the currently, it will be in the same as in the post-development. So again, not only groundwater, for example, that if you get a prolonged sort of a rainfall, even in the existing condition, there will be flooding. So the post-development, there will be flooding, but it's only that we are not worsening it in the downstream.
Thank you. And on a similar vein, Annette is concerned to know whether Powercor is just looking out for themselves with respect to the flooding, or whether they are considering the needs and the wellbeing, safety and property protection of the surrounding residents.
I think the Powercor is by allowing that flood storage within the site and not adverse in the flood to the adjacent property. They are taking care of they consider the risk of the surrounding area, risk to the surrounding area by the development. And also, for example, they recommended the fence that even with the flood storage or the deep flood storage we provided, we recommend to have some fence in there so no public can access to that in the safety concern. So I would say there are considerations that has been taken to in regards to the surrounding and also the public.
Thank you, Amila. And sorry, I just do want to clarify, and on those maps you were showing before, they did incorporate modelling of the surrounding areas, didn't they? They didn't just look at the site itself; they looked around the site.
That's right, Sophie. Yeah.
I did realise that. I'm sorry, I just did miss a question from Sue Stewart. Sorry, from Sue, with respect to the Callow Street drain, just circling back on that for a moment. Will wastewater affect the current water levels of the open stormwater drain on Callow Street? Are you able to comment on that, Amila?
Yeah, so I'm not the wastewater engineer, but I can answer that in a general sense of engineer sense. So usually the wastewater and the stormwater are two different systems. So wastewater comes in a sealed and it's not supposed to join or collaborate with the stormwater. So quick answer would be no. There won't be any issues with the issues from the wastewater to the stormwater in the Callow Street.
Okay,
and
great.
I'll add to that too, Sophie. So our wastewater system and our stormwater system are two separate systems. The stormwater has been modelled as part of Amila's work, and our waste management will be directed into the sewer as per regulations.
Great. All right. Thank you for that elaboration, Ben. Last couple of questions on this topic, and then we'll move to EMF. Nicole asks about site build-up and bench design, whether or not the plan, and Ben, this is one for you, I think, whether you are planning to build up the site on the York Street side, given that it's 1 to 2 metres lower than Callow Street, and whether or not you've thought about how that'll affect water flow onto lower lying areas.
Yeah, no, great question. So Amila in his slides had a 3D map of the site, and you can sort of see that it slopes away quite heavily towards the eastern side of the site. From an overall build-up perspective, while we will be importing material in and changing some of the profile of the site, it will sort of maintain its current sort of direction. So sloping from the west effectively to the east, and similar from York Street back towards the north, so Callow Street. So from an overall build-up point of view, we do build up a little bit in the middle, particularly towards the northern end, but the maximum level that we build up at the moment from current surface levels is about 750 mil, and that'd be about 9 to 10 metres from the northern fence. So from an overall perspective, we keep a very similar overall profile to what the current surface levels are existing.
Great, thank you, Ben. And related to that build-up of the site that you were mentioning a moment ago, Annette asks how much landfill Powercor is planning to bring in, and how far. I think you said 750, but how much landfill will be required to build that up?
Yes. So again, it's probably more of a swap and cut of filler materials. So we will be stripping back the top layer and then building up a compaction layer on top of that. So it's a little bit hard to sort of give exact quantities on that at the moment, given where we're at design. But you know, there won't be I guess a massive build up of the site comparatively to current surface levels. We plan to use that current sort of profile to help with drainage towards the swale and help with the work that Emilla's done. And Emilla's model is all based on that bench profile that we've designed. So.
Excellent, thank you. And one last question on this topic, also from Annette, for now, and I would just reiterate what has appeared in the chat. If we have time at the end after the next presentation and the prepared questions, we will take questions from the chat, but I can't guarantee we'll get to those. However, if you do have questions that arise as we work through, please do drop them into the chat. Anything that can't be answered tonight will be answered and followed up with a document after this conversation. So the last question from Annette, and a pretty important one, Ben. Annette notes that she is reliant on a life support machine without generator backup, and she wants to know, does this mean that every time there is a problem, surrounding residents will lose power?
Yep. So in regards to that, so generally the closer you are to a zone substation, the better your reliability is in regards to power. So the further you get away, the more unreliable, I guess, you are, the more potential there is for unreliability. So for those close to the site, you should see some improvement in reliability if you've got some issues in that space at the moment. In regards to life support customers, so when there are outages, one of my roles in Ballarat is on one of the faults team leaders. So after an hour of any outage, we track life support customers quite closely. If there's any long duration outages, a member from Powercor will touch base with those life support customers, and if they need support in the form of generators or battery backup, then we need to look at providing those sort of things. So that's part of our current process now. And as I said, the closer you are to a zone sub, the better reliability you should be in terms of power.
Brilliant. All right. Well, that's the end of our prepared questions. It's actually bang on time to, with respect to our program. I'm going to thank you, Amila, for your contribution, and Ben for your willingness to answer those somewhat curly questions. I am going to hand over now to Gary. Gary is an expert in EMF. He's an engineer with more than 40 years experience in electromagnetic fields, and particularly in engineering analysis. He's an electrical engineer by trade. He's worked across Australia and internationally, and is a member of the Institute of Engineers. Gary has led a number of EMF related studies and testing, and has a deep expertise in this area. So we're going to hand to Gary now to provide you with some information about EMF at the Ballarat East Zone substation.
Thank you, Sophie. Can we have first slide, please? Yeah, thank you. Now, the electromagnetic field. Today we'll discuss a very important property of electricity, which is electromagnetic field. It's created by current, only by current. There is electric field which is created by voltage, but today we're going to discuss magnetic part of the electromagnetic field. And in the right top left corner, I'm showing the sinusoidal waveform, which is what we get at home when we receive electricity. And that sinusoidal waveform is what you get from voltage. And if you are supplying this voltage to your appliance, you get the same waveform for the current going through the wires. And when you have a single phase power supply, which most houses have, you get only one sinusoidal. When you have three-phase power supply, which some houses have three-phase power supply, or the substation, which is subject of our discussion, is three-phase type of substation, you get three sinusoidal waveform, which are spaced apart by what's called phase angle, 120-degree phase angle. In some other forms, it's presented as a vector, which is down in the left bottom part of the slide. Now, the electromagnetic field spectrum is presented in the right-hand side of this slide, and you can see that it starts from direct current, which is battery supply current, and then it goes next to the power system, which in this instance it's shown as 60 hertz, which is supply system in US and part of Japan. In Australia, we've got 50 hertz power supply system. It's similar to taking a magnet with its two poles and spinning it with 50 revolution per second. You get this type of waveform, as I demonstrated in the top left corner of the slide. And then after that, you get electromagnetic field produced by various appliances, including computers, mobile phones, microwave oven. They produce electromagnetic field in very high frequency range, 2.4 gigahertz, and then visible light, which is even higher frequency, and then we go into ionizing radiation, which is X-ray and gamma rays and so forth. Now, the electromagnetic field of up to visible light has not sufficient enough energy to cause ionization of biological cells, while X-rays and gamma rays and even the ultraviolet light have enough energy to ionize biological cells, so cells. Now, the next the picture on this slide shows the level of low frequency electromagnetic field, in this case only magnetic field, starting from distribution lines down below. You can please note the values. It's from 2 to 30 mellingauss, and from 0.5 to 10 millingauss, and a 10 meter distance away from power lines. Then we have next power line is much larger lines with higher voltage lines. You get a stronger field, and then some household appliances. You can see the values ranging from 2 milligauss up to 70 milligauss, depending on the appliance. Next slide, please. Now,
Gary, I'm just going to jump in there. Would you mind popping your camera on for us? And also, we're having a little bit of trouble with your mic. Would you mind just putting yourself on mute and then unmuting yourself again, see if that fixes the problem?
Okay.
Thank you.
Is it better?
Sounds a bit better now. And pop your camera on too if you're able, but all right if you're not.
Okay. Is that better?
No, we still can't see you, but that's okay. Press on.
Oh, sorry for that. My camera is on. I don't know what's happened. Yeah. On this slide, I'm trying to show you the whole structure of the power supply system. In the left-hand side, you have the power station, which is a conventional power station with burning fossil fuel. You burn the fuel, you virtually heat the water. Water turns into steam, and steam has enough energy to turn turbine. Then you turn generator, which is connected to turbine. You produce electricity at reasonably low voltage. In this instance, is 21,000 volts. You have transformer which increases that to 5,000 volts. The reason that voltage is going up is that your aim is to transmit as much electric energy as possible. Now, the electric energy is I've got the equations in the middle. Electric power is the product of voltage and current. Now, if you want to transmit very high power, you have to have high voltage and high current. Now, if you have very high current, passing through wires is causing power losses. Now, in order to minimize power losses, what happens in power system, we tend to increase voltage as much as practicable in order to reduce current so that we minimize the losses. And the power loss equation is written below. It's very simple. It's a function of current squared times resistance of wires. Now, so it means a good sense to increase the voltage when you're transmitting energy to long distances. And in Victoria, we have the highest voltage is 500,000 volts. We transmit it through very large power lines, and then when we come to large large towns where there is a high concentration of electrical load, we reduce the power, reduce the voltage, and then transmit it at lower voltages, in this case 220,000 volts, and then further reduce it down to sub-transmission voltages, which is 66,000 volts, and then further reduce it using the distribution substation, which supplying residential, commercial, and industrial sites. At 400 volts, it's three-phase, or single phase is 230 volts. This diagram is quite sort of revealing what happens with the power system. Next slide, please. Now, this slide shows the site where this new substation will be constructed in the top left corner, and then physical arrangement in respect to houses adjacent to its western side, and to its eastern side there is a space between the eastern boundary of the substation and the houses. Now, on the right-hand side, it shows the design arrangement for this substation. You can see three sort of lines which are going vertical. This called bus bars. The bus bars are within the substation, designed to redirect the power flow through various parts of the substation until it hits the transformers, and then transformers will be erected along the eastern boundary of the site. Now, the slide in the middle shows the three-dimensional model of this substation. In order to calculate the EMF, I've constructed three-dimensional model of this substation site with all three transformers in service, and the two slides in the middle and the bottom of this. Sorry, two pictures in the middle of and the bottom of this slide represent this three-dimensional model in two different sort of arrangement. Next slide, please. This slide shows the first stage of this substation development, where it will be fitted with only one transformer. Transformer is shown here on this diagram as double circles. This is transformer, and the the substation will be supplied or connected to two power lines. One will be supplying current into the substation, and the other one will be taking this part of the supplied current further away along the transmission network, feeding some other zone substation. So now in this diagram, I demonstrated how this current will be distributed along different parts of this substation. And this distribution was taken into consideration when EMF was calculated. And the graphs here on the right-hand side of this slide shows the EMF profile along western and eastern fences of this site. And the western fence is along the left-hand side of this substation diagram, and the eastern fence, of course, along the right-hand side. As you can see from this graph, the highest calculated magnetic field for the western perimeter fence is just below 8 milligauss. 8 milligauss by itself is very low figure. If you remember the previous slide where I demonstrated how much EMF is produced by street power lines, you can see that 8 milligauss is even below what the street power lines are producing. Now, the blue graph shows the EMF profile along the eastern boundary fence, and the profile is even smaller. The highest field there will be less than 1.5 milligauss. Next slide, please. Next slide, please. Yes, thank you. Now, this slide shows next stage of substation development, which most likely will happen in 5 years' time after the first stage is completed. Now, at this stage, the substation will be fitted with the second transformer, and the current through the substation will slightly increase. It will be 400 amps coming into the substation and 50 amps coming out of the substation. That will be the maximum current rating of the substation. And the EMF profile calculated from three-dimensional model shows that the highest field along the western perimeter fence will be just under 7 milligauss. Now, the highest field along the eastern perimeter fence slightly increases to under 2 milligauss. Now, as you can see, the shape of this profile is slightly different because it's a substation will have second transformer, and the current distribution through the system of bus bars will be slightly different. Next slide, please.
Yeah, I'm just going to jump in there. Sorry for a moment. I'm conscious you've still got this is essentially very important content and very much what people have come to hear. I'm also very conscious of time. So if you're able to be as economical as you can with time for the next little bit so we can make sure we can get to those prepared questions.
Yes,
thank you.
Sophie. Yes, sorry. This slide shows the ultimate development of the substation with 3 transformers. That development, most likely will take place in more than 20 years after completion of the first stage. Now, the EMF profile is shown just below that graph, and you can see that the highest field will be just slightly above 12 milligauss. Now, the table below shows the stages of substation development with maximum field along different perimeter fences. Now, next slide, please. Now, this slide shows the graph shows the consumption, electrical power consumption through the substation, and you can see that it's in terms of time over the 1 year period. Now, the highest power, highest current through the substation will be on average, which is the annual green line, will not be greater than 450 amps. Now that it shows that a very small number of hours will be during that highest current period, but on average, the substation will be loaded to about 50% of its capacity, even in many cases less than 50% of its capacity. In that case, the current will be less than 200 amps coming through the substation. So this is important to understand what will be the average electromagnetic field emitted by the substation. Next slide, please. Now, this slide shows also very interesting and important graphs. Now, EMF produced by transformers or any equipment with coils like electric motors, generators, transformers reduces inversely proportional to the cube of the distance away from the unit, which means a very fast reduction of EMF with distance. Now, EMF produced by bus bars reduces inversely proportional to the square of the distance, which is a red line. It's still quite a rapid reduction of EMF with distance. Now, the dark color line represent EMF reduction from single wire power lines, which are rural lines, and also from, which is interesting, from water pipes, which are metallic water pipes. Some water pipes can carry out currents, and the EMF produced by them reduces very slowly with distance. Next slide, please. Now, this slide shows how close the power line is to the building, which is a commercial building, and you can see that the conductors are spaced apart, and the electromagnetic field inside this building is, considering the proximity of the power line, is quite high compared to what I sort of calculated using the three-dimensional modeling with current. Next slide, please. That's practically concluded my presentation, because what I'm trying to say is that the magnetic field produced by this zone substation will be extremely small, and the reduction of field with distance will be quite rapid. And, in my opinion, there is practically no issue related to any sort of physical or physical danger to health, because the calculated electromagnetic field is much smaller than what's recommended for health exposure. It's also much smaller what is recommended in terms of interference with the electronic devices. So there is no issue with either of these two important issues.
Great, thank you. And Gary, we'll swing straight into questions. And Ben, I've got a couple for you as well, if you can be ready to go. The first one is from Nicole, and I think you answered this. I think this was in the graphs on your and tables on your presentation, Gary. But Nicole asks about the expected readings on the site at the boundary, and then at 20 metres, 50 metres, 100 metres, 200 metres. I understand that was the graphs you were showing earlier. Is that right?
Yeah, well, the graphs which I showed practically show the EMF profile along perimeter fences of the zone substation. Now, the graphs which I showed later in my presentation shows the reduction of EMF with distance, and if the field at perimeter fences is very small, and the reduction with distance is inversely proportional to the square of the distance from the bus bars or the substation, then EMF at more than 10 meters away from the substation fences will be immeasurable, practically immeasurable with modern devices. It will be that small.
Excellent. That's good to know. Thank you very much. The next question is also from Nicole, and Nicole wants to know, will there be different levels that would be experienced in her house as opposed to outside in her garden?
Well, definitely, if the garden is very close to a substation fence, again, it's a function of distance. If the garden is very close to substation fence, then the field will be in the garden will be slightly larger than inside the house. But again, because of the effect of distance, the levels will be very small, whether they in the garden or inside the house.
Good, Gary, thank you. A question from Annette, a comment first. Annette observes that we, which I presume means Annette and her neighbours, believe this is the wrong spot in the middle of our homes for a high voltage major substation. But her question is, will EMFs bounce off the dirt?
No, the EMF virtually is not affected by soil. Soil is acting to a magnetic field the same way as air. So if you imagine you have a magnet and you the magnetic field of 50 hertz, it's similar to a magnetic field from a magnet. Now, if the soil is not mitigating magnetic field from the magnet, the soil will not be mitigating magnetic field from electrical power sources.
That's great. And thank you, Gary. Before I go on to the next question, I'm conscious that we're only 3 or so minutes from our scheduled end of this session. If everybody's comfortable, we would rather be able to answer the prepared questions or the questions we received ahead of the session. So if you're happy to stay on the line with us for 5 or 10 minutes to get all those questions answered, we'd be glad to have you with us until the end. Gary, another question from Nicole. If EMFs are high in the area, what can be done to reduce them, and what is too high?
Well, yeah, in this instance, the EMF from this substation, the way it was designed by Powercor, EMF from this substation will be very, very small. And you know, the issue with the EMF is that there are a number of ways that EMF can be reduced, but what is reasonable? What is the reasonable level of EMF? Now, in my opinion, the level which I've calculated through modeling is extremely small. It's smaller than people can measure under street power lines. If you have power supply from the street power line and you're standing under power line or 5 meters away from the power line in the street, you will have this smaller, you will have larger EMF from street power line than what you get from this substation. Simply the way it was designed and arranged in the available space, the EMF will be quite small outside the substation boundary fences.
Great, thank you, Gary. Ben, one for you. Nicole wants to know if they choose, Nicole and her neighbours choose to monitor EMFs at their properties, who would they notify if they believe they've seen a reading that is too high?
Yeah, absolutely. Thanks, Sophie. Yeah, the best way to manage that is to call our contact centre on 13 2206. They'll raise a case and we'll send someone out with or send the appropriate person out to monitor that and take some more readings and to verify that. And if we have to, we'll rectify it.
Great. And while you've got your mic unmuted, Ben, I might get you to take the next one too. Peter makes a comment initially, observing that he believes that the area could become derelict or his investments become liabilities, so he and the public need to be well informed. And if it does go badly, expects that there would be room for compensation. And it believes because he bought more recently, he would have more to lose than people who bought their homes 10 years ago. After that comment, there's also a question about how much EMF is dangerous, and if so, how will it be contained and monitored so that people can be comfortable and safe living in the area?
Yeah, well, like I said, we've engaged Gary as a preeminent expert in EMF to model what the levels might look like. Once we've constructed and we're in service, we'll get Gary back to monitor actual levels, and we'll do that at the various stages of development of this site. So from that point of view, we're informed, and we'll also inform our surrounding neighbours of what those levels are, and keep everyone sort of in the loop in that case. In regards to the comment, we have zone substations in residential areas, all over the state. We don't generally have EMF issues at any of those sites, even ones that are close to neighbouring houses like Ballarat East will be. And in regards to electrical infrastructure creating derelict neighbourhoods, it's just not our experience. It's not what we see at any of our other sites. We've got over 80 subs between Powercor and City Power, and more in UE. And again, like I said, a lot of them are in residential areas, and we don't see that from our perspective at our current sites.
Great. Thank you, Ben, and thank you for tackling that one head on. Gary, I'm going to collapse the next couple of questions into one sort of big question, comprehensive question, which relates to the topography of the site and the broader area. Nicole and Annette observe that York Street is situated in a valley and the site is situated in a valley. They want to know whether or not EMFs hang around longer because it's a valley, whether you have other substations or you're aware of other substations situated in valleys, and whether they have different readings from from substations that are not situated in valleys, and whether or not there are substations in places where the land rises by Annette's estimate 10 to 20 metres.
Yeah, okay, thanks, Sophie. As I previously mentioned, electromagnetic field is created by current. If there is no current, there is no electromagnetic field. So field as such is not standing in one area. It's not like a fog, physical fog. It immediately reduces to zero if there is no current. And it's directly proportional to the current. The stronger the current, the stronger is EMF or magnetic field. The smaller the current, proportionally smaller the magnetic field. They directly related to each other. Now, sorry, what was the second part of the question, Sophie?
Whether you're aware of substations in valleys and whether the EMFs perform differently in valleys than they do, or behave differently in valleys than they do on flat land.
Yeah, there is absolutely no difference between substations being in the valley or raised up above the ground. As I said, the EMF is directly related to current, and the important factor is distance between the EMF source and the receptor of that magnetic field.
Great, thank you, Gary. Again, I'm going to sort of collapse these questions together, both relating to health, one from Nicole, one from Annette, about the impact of EMFs on the health of babies, older people, or the elderly, people who already have cancer. And yeah, it's essentially the same, and any other vulnerabilities. Those are the questions.
Yes, Sophie, electrical engineer. I'm not the expert in biomedical science or medical science. I read a lot of publications on this subject, but I prefer not to make any comments because that's not my area of expertise. All I can say is that the calculations performed for this site results in very low level of EMF, and it's much smaller than what, as I mentioned before, what people can experience in other areas, like even suburban street under power lines. And if they're comfortable walking along the street with power lines, then there shouldn't be any issues, living next to this substation, in my opinion, in terms of biomedical impact.
Okay, thank you. Thanks, Gary. And last question for you, Ben, and then we'll wrap up. I would remind people, if there's any questions that have occurred to you, we have gone well over time now, but if anything has occurred to you and you want answered, the team has agreed that they will take any questions on notice, get answers to you and email the responses back to the participants on the call. So if there's anything you feel like you had the presentation has raised for you, or you've got an additional question you'd like to elaborate it on, please do put it in the chat and the team will respond over the next few days. Ben, the last question is one for you. Lorraine wants to know whether an EMF map or a report will be provided to residents in neighbouring properties.
Yeah, good question. So we'll be releasing an EMF fact sheet that will cover some of the stuff that's in Gary's report that's fed into tonight's presentation. That'll go up on our project site very shortly. There's probably just one thing I wanted to add there too, Sophie. So the work that Gary's done has also informed our design. So as Gary said, EMF is a function of distance. So when Gary did his modelling and the outputs of that came to us, we've actually looked to increase the distance between the western fence and our 66 kV bus bars. So we expect that the EMF values that Gary modelled when we actually finalise the site and put into construction will be much lower than what we've actually modelled as well.
That's a good thought to leave us with. Thank you, Ben. All right, Ben, Gary, Amila, thank you so much for your presentations and your expertise tonight and your willingness to be open in answering those questions. Thanks also to the Powercor team for setting this conversation up. I'm sure this won't be the end of the conversation. Thanks to everybody for attending tonight. As Amanda's just dropped into the chat, more information is available on the Powercor website at Ballarat East ZSS. All recordings and questions and answers will be published on the site in coming days, and it will be emailed to you if you're registered for this event. Do expect an email with both the recording of this session and also the Q&As. If there's anything further, please do drop it in the chat and the team will come back to that in coming days. And thank you everybody for staying online till 7:10 at night on a cold Victorian winter's night. Go and enjoy some time with your families, and thanks very much for taking part.
Thank you.